We wish you a Merry Christmas. We wish you a Merry Christmas. We wish you a Merry Christmas and a Happy New Year. The tidings we bring to you and your kin. We wish you a Merry Christmas and a Happy New Year.
And continue with our items. So item 6, an industrial company aims to produce a useful element from copper 1 sulfide, a black powder. This involves roasting copper 1 sulfide in controlled amounts of air according to the equation below. So the company wants to determine the mass of element that can be obtained from the reaction for further purification, as well as the volume of the gaseous product, as this gas has potential industrial applications. Prior to the full-scale production, an experiment was conducted where 32.0 grams of copper 1 sulfide was reacted with excess air. So what do we have in this case? We are provided with 32.0 grams of copper 1 sulfide, and we are tasked the tasks here, or the challenges which are being posed by the item. They want to determine the mass of the element that can be obtained from the reaction, and that element is copper. Mass of copper, as well as volume of the gaseous product. The gaseous product is sulfur dioxide gas. So given 32.0 grams of copper and sulfide, we want to determine the mass of copper and the volume of sulfur dioxide. So part 1 says calculate the mass of the solid product formed, given this information in the bracket. Then part 2, volume of the gaseous product measured at STP, given that 1 mole of a gas occupies 22.4 decimeters cubed. So we are going to start with part 1. Part 1, mass of the solid product. What is the solid product? Copper. What are we provided with? We are provided with 32.0 grams of copper 1 sulfide. So therefore, we shall have the following. Therefore, for Roman 1, recall that we make a pathway. Starting with, we have to use what we have to obtain what we do not have. As in, you start with what is given. We are given mass of copper and sulfide. So we can convert this to moles of copper and sulfide. Then from moles of copper and sulfide, we can obtain moles of copper. So we compare moles of copper and sulfide and the given equation. So we compare moles of copper and sulfide and the given equation to obtain moles of copper. Then we shall convert moles of copper to mass of copper. So we start with a number of moles. We have our mass as 32.0 grams. Recall that number of moles, this is equal to mass of copper and sulfide over RFM of copper and sulfide. The mass of copper and sulfide is 32 over RFM. From the information, we calculate RFM using the information in the bracket. From the information in the bracket, they have told us that 1 Cu is 64, and there are 2 atoms of Cu, there are 2 atoms of copper. Therefore, we shall say 64 times 2, then plus 32, which is capital S. From the information in the bracket, capital S is 32. Therefore, computing this, we obtain 32 over 160. And this gives us 0.2 moles of copper 1 sulfide. Now, since we have moles of copper 1 sulfide, we use these moles and the given equation to find moles of copper. So which concept do we apply in this case? That is the concept of mole ratio. Mole ratio, we compare what we have, which is copper 1 sulfide. So we are looking at the ratio of copper 1 sulfide and copper. So what does the equation stipulate? The equation says that, maybe to take you back to our equation, this is our equation. The equation says that 1 mole of copper 1 sulfide produces 2 moles of copper, as in 1 copper sulfide gives 2 coppers. Therefore, the reaction ratio is 1 to 2. As a result, we shall have the following. We shall substitute in our ratios. So the ratio of copper 1 sulfide to copper is 1 to 2. However, if the ratio is 1 to 2, then what if the moles are 0.2? 0.2 moles of copper 1 sulfide. Therefore, 0.2 moles of copper 1 sulfide, here we shall have 2 over 1. If one produces 2, if 1 mole produces 2, then 0.2 moles will produce 2 over 1. 2 over 1 then times 0.2. And multiplying this out, we obtain 0.4 moles of copper. So we have moles of copper. We use these moles to obtain mass of copper. Therefore, what do we apply? Number of moles in this case is equal to mass of copper over molar mass of copper. We substitute number of moles as 0.4. We have the moles. The mass, we do not have it. The molar mass of copper, according to the information in the bracket, this is 64. Therefore, we make mass the subject by cross multiplication. So as a result, we shall have mass equals 0.4 times 64, and this gives 25.6 grams of copper. So this is approach 1 to item 6, Roman 1. Then we can look at approach 2 to item 6, Roman 1, the technical approach. This approach is technical. Why am I calling it technical? It's simply because it requires you to interpret the equation. So we are provided with mass of copper 1 sulfide. So what does the equation say is that? What does the equation stipulate? The equation stipulates that, this is what the equation stipulates. We have seen that 1 mole of copper 1 sulfide, from the equation, 1 mole of copper 1 sulfide produces 2 moles of copper. And we know that from the previous videos, if you are watching this video for the first time, I'll recommend you to the first videos where we saw the interpretations of these things. For example, we are going to say that 1 mole of copper 1 sulfide, 1 mole of copper 1 sulfide is RFM, from what we covered. And RFM of copper 1 sulfide, Cu, copper is 64, but there are 2, so 64 times 2, then plus 32 for capital S. This produces, these grams of copper 1 sulfide produce, then these are 2 moles of copper. 2 moles of copper, correct this, it is not 2 mole, but 2 moles of copper. 2 moles of copper, still we are going to substitute molar mass, but there are 2, and each Cu is 64. So since there are 2, we shall have 2 times 64 grams. Therefore, substituting in, computing this information of copper 1 sulfide, we obtain 160 grams of copper 1 sulfide, produce, then 2 times 64, this is 128 grams of copper. Then what of 1 gram of copper 1 sulfide? 1 gram of copper 1 sulfide produces, so if 160 grams produce 128 grams of copper, then 1 gram will produce 128 over 160. Then what of the 32 grams in question? The 32 grams in question will produce 128 over 60 times 32 grams of copper. And computing this, we obtain mass of copper as 25.6 grams. Allow me first stop here.